During penetration testing, sometimes you encounter a scenario where your client is using some kind of an internal server where this server is not accessible through the internet, and just because of that they think it's secure. In this video we will see how we can integrate a simple port scanner with our script for a possible attack pivoting. Usually, once you got into your target machine, you start looking for other possible targets. For example, if we were able to access into machine A, then we can extend our attack and scan a target B to see what ports and services are running on that machine. Other usage for that is to make the target scan an online server on our behalf to hide our activities. Now let's go to the coding part. As the title said, we will build a basic low-level scanner, and I call it low-level because we will use the built-in socket library and then build on it. The formula or the format for sending scan request is scan, then space, then the IP address, then we have a colon, then the port list. Now the first thing to do is to cut off the leading first character here. So this part will be removed. After that, we will split the right part into two sections. The first section is the IP address that we want to scan, and we will store it in the IP variable. The second variable is the list of ports that we want to check its status, and it will be saved in the ports variable. To keep the code clean, I made an entire function called scanner to do our stuff. So we will pass the socket object, the IP, and ports variable to this function. Let me go up a little bit so we can see the full function here. Okay, so once we got this variable, we will define a scan result as a variable which stores our scanning result. Now remember that the ports are separated by a comma like this format. Let's say 21, 22, port 80, 443, and let's say 445, for example. So what we will do, we will loop over each one of these ports, and we will try to make a connection using a socket library for each one of these ports. Notice that I have used connect_ex function, where this function returns 0 if the operation succeeded. And in our case, operation succeeded means that the connection happens, which means the port is open. Otherwise, the port could be closed or the host is unreachable in the first place. At the end, we will close the socket and repeat the whole process till the last port in our list here. So we will go for port 22 till reaching the last one. The result of our scan will be stored in the scan result, and the plus sign is used to append the result. Finally, we send back the result to our Kali machine here. Since our Kali machine and the target are on the same virtual subnet here, so we should appear on the target ARP table. Let me run the script for now, and I will do ARP-A here. And this is the IP address of our Kali, 10.10.10.100. So as a proof of concept, I will scan our Kali machine from the target side, and I will run Wireshark to confirm the scanning. So for now, let's do a scan for port 21, 23, 80, 443, 137, 138, and port 8080. So I'm gonna run the Wireshark. I'll filter on TCP. And fair enough, once we run this command, we can see the TCP session comes over here. So in the scan result, we can see that port 8080 is opened and all other are closed. So let's check if we can see the completed three-way handshake for the TCP on port 8080. Okay. So this is the scan for destination port 8080. This is for 21. And if we scroll down, and yes, here it is. You can see the send ACK, then ACK for completing the three-way handshake. And we can see that the target after completing the three-way handshake is sending a fin request to close up to close the socket here, because we specified to close the socket after the scanning. If you still remember in the code here, we said sock.close. So the fin is as an indicator to close the socket. Okay, now to double check, let's open a terminal to see what the process is using port 8080. So, and it's opened by another Python script. Okay, let's do the same for port 21, and I will change this one 21, and fair enough, we got nothing since the port is closed. Let's do another test, and I will use a netcat to open port 21, then I will do the scan again to see if the result is gonna change. So right now we are nestling on port 21. Let me just verify that. Okay. So let's go back to our shell here and scan on port and repeat the same scan. If it's working, we should see port 21 as opened. And here it is, it's opened right now. Thank you very much for watching.